It's one small step for man, one giant leap for mankind.
This is a special episode of Here's an Idea. I'm Billy Hurley, and we'll be sharing my full interview with Daniel Coleman, editor of the publication known as NASA Spin-Off. As we celebrate the 50th anniversary of Apollo 11, we of course remember the moon landing, the planting of the American flag, and Neil Armstrong's famous words. The 1969 lunar mission, however, also gave us a variety of everyday technologies that we may rarely even notice. The 1958 Space Act charged NASA with finding the widest practical application of its technologies and sharing the benefits of the results of its missions as widely as possible. In other words, the technologies employed in space can and should be used, or spun off, here on Earth.
My name's Daniel Coleman. I'm the editor of NASA's Spin-Off publication.
First published in 1976, the NASA Spin-Off Annual Report has since highlighted more than 2,000 commercialized technologies that began on NASA's space missions. I spoke with Daniel about the most significant spin-off technologies from the Apollo program. You may be surprised at the everyday tools and materials that began with one small step toward the moon.
Spin-Off is an annual print product that NASA's published since 1976, and it explores all the ways that NASA technologies benefit us and benefit your life. We've covered, at this point, more than 2,000 technologies that started in NASA missions or with NASA funding, and they spun off and commercialized. And as editor, I'm kind of in charge of getting the publication together each year. We've got a small team of writers and a graphic designer. So we go out and find leads, find companies that are using NASA technology or who have worked with NASA. And we write stories about the NASA origins of their products and now what they're doing today.
And to set the stage, you kind of went into it, but when we say spin-off, what exactly is a spin-off technology?
A spin-off is any technology that's now a commercial product, but which has its origins in NASA technology, either to solve a challenge in space exploration or also in aeronautics. And these are technologies that were designed for one purpose, for NASA's mission, but as is often the case with technology, it has broader applications. And so NASA's also in the business of facilitating businesses to look into potential applications of NASA technology for practical problems in the commercial sector. And so anything that makes that transition from a NASA origin technology into a commercial product is a spin-off.
Right. And so why is it so important to have these kinds of relationships and these kinds of spin-off technologies?
When Congress created NASA with the 1958 Space Act, they actually wrote into the legislation that created the agency that NASA was going to be charged with finding the widest practical application of its technologies and in sharing the benefits of the results of its missions as widely as possible. So it's actually part of NASA's mandate to share these technologies. And we don't go to space, we don't do space exploration in order to create these technologies. The fact is that when you push the boundaries of what's possible, when you do things that haven't been done before, when you solve completely new challenges, the technologies you create just have these wider applications. And so part of NASA's mission is to make sure that the hard work and the taxpayer dollars that are a kind of investment that gets put into creating these technologies in the first place, that gets back to the taxpaying public, that the public benefits from their investment in aerospace.
With your job as editor and you see all these kinds of spin-offs, is it the kind of work where you're surprised by the kind of range of applications?
Yeah, well, I've learned not to be too surprised, but you find spin-offs everywhere. It's really not that these things kind of stay in the area of engineering. There's a ton of consumer products that are spin-offs. There's all sorts of medical applications to technology that might originally have been developed, say, to work on a satellite. We've got an enormous number of spin-offs that serve public safety and what else? Transportation, cars, aircraft, in factories, and certainly we've got a lot of information technology spin-offs as well. So it certainly is. It can be surprising when you look into it, just how ubiquitous NASA technologies are in society.
And just to give a kind of reference, what would you say is the most well-known or some of the most well-known NASA spin-offs?
Sure. The camera in your cell phone is a NASA spin-off. The digital imaging sensor, known as a CMOS sensor, it's a complementary metal oxide sensor, was originally created by a NASA engineer to make a smaller camera for space than the existing, I think it's CCD technology. But the existing technology was a little bulky, and he developed this CMOS sensor that has since become the standard in digital imaging cameras. So the camera in your cell phone, if you've got a GoPro, that uses NASA technology. One material that everybody's familiar with is memory foam. It's in beds, it's in airplane seats, theater seats, it's in pillows, couches. And memory foam was actually developed out of a NASA project that was looking at safety in aircraft.
And so you sent along this really helpful list of, I think it was 35 or so spin-off technologies from the Apollo 11 mission. And we can't go through every single one. So I was sort of hoping that maybe you could highlight a handful of spin-off technologies that you consider to be the most important from that mission.
Sure. A lot of stadiums around the United States and around the world utilize this white fabric, tensile fabric that's used in architecture. It's unmistakable once you see it. I think it's in the Dallas Cowboys Stadium, and it's in the Atlanta football stadium where they most recently had a Super Bowl. And that fabric actually came out of following the Apollo 1 tragedy. The Apollo 1 crew was doing a test, and there was a fire in the capsule that unfortunately killed the crew. And in the wake of that, NASA was looking to revamp everything and make sure that all of the systems were safe. And one of the things that they did was they decided to redesign the spacesuits, in part to make them fire resistant. And they looked for a material that would be durable, strong, lightweight, flexible, and non-combustible. And what they settled on was a fiberglass fabric coated with Teflon. And the company that helped NASA develop this new spacesuit went and spun that off as an architectural fabric, and it's all over the place now. Another spin-off that has kind of become ubiquitous is a set of food safety standards known as the Hazard Analysis and Critical Control Point concept. That's HACCP. And as NASA was looking to send people into space, it needed to pack everything they needed ahead of time to go with them. And in particular with food preparation, NASA was especially concerned that the astronauts weren't going to get a stomach bug when they're out in orbit around the moon. And so they worked with Pillsbury to come up with new ways, new standards for testing the safety of food. All of this was like vacuum-packed food that they sent with the astronauts. And Pillsbury turned around and started using this standard themselves, and it's actually become kind of the industry standard in food safety.
Are there other spin-off technologies that you'd like to mention that are related to the Apollo mission?
Mm-hmm. Yeah, there's one more I'd mention, which is the technology of fly-by-wire systems. So in early flight, when a pilot pulls back on the joystick, that actually moved through cables and physical parts. The pilot would actually be physically moving the plane by moving components around. And the technology of instead of flying things that way, but instead having a flight computer where all of the input from the pilot would go to the computer, and then the computer would send out signals and control parts through this digital connection. That actually came about in order to enable the Apollo guidance computer, and it was used during the Apollo missions. And so NASA has a major flight research center. Nowadays it's called Armstrong Flight Research Center. At the time it was Dryden Flight Research Center. They worked with this technology and developed the first fly-by-wire aircraft. And for the first time, these pilots were not controlling the rudders and the various mechanical components themselves, but a computer was doing it. And nowadays, that's everywhere. I mean, every flight you take, every commercial aircraft is using fly-by-wire.
Are there any spin-off technologies from Apollo that we'd maybe be surprised to learn were from the Apollo mission?
Sure. People might be surprised to learn that emergency blankets, or otherwise known as radiant barrier insulation, that's that thin metallized sheet that's highly reflective, that actually came out of research into how to insulate astronauts in space and also how to insulate spacecraft. If you had an astronaut out in the extreme temperatures of space and you used typical insulation, you'd need a spacesuit that was feet thick rather than inches or even less than that. And so NASA needed something that was obviously a lot more flexible and easy to work with. And so early NASA research led to this now very common material. Another one that's probably a bit surprising to people would be to learn that their hearing aid batteries may be a NASA spinoff. There's a company that picked up on NASA research into using silver zinc batteries, rechargeable silver zinc batteries, just for various technical reasons is a very difficult technology to pull off. NASA looked into this and used some silver zinc batteries during the Apollo missions. It still was kind of a niche a niche technology, and so NASA continued to research its use over several decades and eventually kind of dropped it. But then this company went back and looked at the NASA research and decided that there was still potential there. So the company took that technology and added a couple of like a decade or so of their own work and research into it and came out with this product, which is a silver zinc rechargeable hearing aid battery. So these hearing aids are small and they're powerful. They last all day. They can be recharged again and again. And this solves what's a very common problem for those who use hearing aids, that they're constantly going through batteries. And actually, in some cases, folks will compensate for a low battery by turning off their hearing aids for a certain amount of time during the day. And so this lets them run all day.
And we remember Apollo 11 for the obvious moments, of course, the moon landing. In this context of what we're talking about, are there any aspects of the mission that you think may be overlooked or that are important for us to remember as we approach the anniversary of Apollo?
I think most people appreciate that in order to get to those big moments, planting the flag in the moon and landing there, getting into orbit, what got us to those big moments, the moments we're going to be celebrating this summer during the anniversary, were a lot of smaller moments when there were challenges and all sorts of obstacles that thousands of people who were working at NASA at the time faced. And thanks to their genius and their determination and their sacrifice, they created so many technologies that came out of NASA at that time, many of which became spin-offs. And so I would say that as we celebrate the moon landing anniversary this summer, people should take a little time to reflect on all those thousands of people who made those flights possible, who made Apollo possible, and think about how at the time it wasn't a given that we were going to make it to the moon, and that we got there because they solved one problem after another. And thanks to those people, among other things, we not only landed on the moon, but we also have these secondary benefits in the form of spin-offs that benefit life on Earth even today.
Do you notice a difference between the sort of spin-off offerings today versus the spin-offs from Apollo, or does it just kind of progress with how technology is progressing?
I think it's a bit of that. I think it progresses as technology progresses. Probably the biggest difference that I see is that a lot of the spin-offs we write about today have some kind of software or digital component. There's a lot of use of data, for example. Satellites are now a huge part of the space program, particularly Earth-observing satellites. And back in Apollo, we didn't have nearly as many. But nowadays, they're used for weather, for GPS, and we do have some NASA spin-offs in those areas. But also just things like the Earth observation satellites give farmers all over the world benefits. Farmers, thanks to NASA satellites and the data they provide, their software that gives them predictions of crop yields, for example. It's also the case that most farmland is worked by self-driving tractors nowadays, and that's thanks in part to NASA software that does some key corrections to GPS data, which makes it accurate down to inches rather than feet. And That relies on the precise GPS as well as some internet-based tools, and all that's infrastructure that didn't really exist back then. So the technologies, thanks to some of the digital infrastructure and software, can have a global reach in a way that I don't think we really saw during Apollo. Another big area is robotics. We've had a number of commercial products that have come out of NASA research and missions that utilize robotics. Maybe you've heard of the Robonaut, the first robot astronaut. Mm-hmm. And thanks to that project and some others, we've one Spin-Off is a robot that will, in battlefields, it'll go into dangerous situations for reconnaissance, can go into minefields and keep soldiers safer. There are other robots that are used in by like city governments and county governments to look into sewers and things like that. That also has come out of NASA technology. And then I think finally I would say it's one area that might be kind of surprising are small business partnerships. NASA is part of the Small Business Innovation Research Program, and that's a program that allows NASA and other federal agencies to work with small businesses who have small budgets and small staffs. And they give them a little bit of money, and that allows these businesses to try to tackle big problems that no one else is working on. And so a lot of early stage technologies get a little bit of funding that way. NASA gets to test out a lot of different ideas and see what works and see what doesn't. There's not a lot of risk because there's not a lot of money. But in many cases, the companies kind of move through this program and get one contract after another. And they're able to take a technology from early stages on through to commercialization. And so we write a lot about those in Spin-Off each year. We've got probably about a dozen or so SBIR small business technologies in the book each year.
What do you think are the best, most valuable ways to keep those kinds of lines of communication open between businesses or organizations who are hoping to commercialize NASA technologies?
I'm going to answer a slightly different question than the one you asked, if that's okay.
Sure.
Businesses that are interested in NASA technology can look at NASA's entire intellectual property portfolio. All of that's at technology.nasa.gov, and that's NASA's technology transfer program. And so we host on that website, I think it's more than 1,000 patented technologies that are currently available for license. NASA also has a comprehensive software catalog that's hosted at software.nasa.gov, and anyone, not just businesses, can look through this software catalog and can find tools that they can use, and almost all of it is for free and available. So you just you basically apply and then acquire the technology pretty quickly. So NASA has those websites, and in addition to the Small Business Innovation Research website, there are a number of ways that businesses can either look for what NASA has available or to get in touch with NASA to find out whether there's something that they can partner on.
This has been a special episode of Here's an Idea. For more information about the technologies featured in today's podcast, you can visit our episode page at techbriefs.com/podcasts. Our podcast page also gives you an opportunity to subscribe to our Here's an Idea newsletter, which provides photos, facts, and follow-ups on the technologies and technology creators featured in each episode. All this month on Tech Briefs, we are celebrating the 50th anniversary of Apollo 11. Go to techbriefs.com to read our Apollo 11 article series. And we want to hear from you. Give us a review on Apple Podcasts and send us feedback to podcasts@techbriefs.com.